Hello students, welcome to Educate. Today we are going to continue with the questions in chapter Work, Energy and Power. I think page is visible. I am making it little bigger so that you can see. Here we are going to do question number 5.17. The bob A of simple pendulum released from 30 degree to the vertical hits another bob B of the same mass at rest on a table as shown in the figure. How high does the bob A rise after the collision? Neglect the size of the bobs and assume the collision to be elastic. Elastic collision means what? Do you remember? Elastic collision means momentum and kinetic energy both remains conserved. So here what will happen? When this bob moves to this position, it reaches here and it hits this bob. Its entire energy will be transferred to this bob and bob A will come to rest. So here question says the bob A of mass of pendulum released from 30 degree to the vertical hits another bob B. So it is hitting bob B of the same mass at rest on a table. Here its velocity is 0. How high does the bob A rise after the collision? As I told you, entire kinetic energy of bob A is getting transferred to bob B. Hence, bob A will come to rest and bob B will move in horizontal direction. So, I think you have understood the answer to this question. Now consider next question. Question is, the bob of a pendulum is released from a horizontal position. If the length of the pendulum is 1.5 meter, what is the speed with which the bob arrives at the lowermost point, given that it dissipated 5% of its initial energy against air resistance? So question is simple. Let's analyze the situation. Here situation is like this. This is initial position and now it will come to this point like this. In our question, length of pendulum is given as 1.5 meters. So this is 1.5 meter. This is also 1.5 meter. Now what is happening? Here we are going to apply energy conservation principle. So we will find energy at point A and energy at point B. What is the condition? Condition says whatever energy it possesses at this point, 5% of it is lost due to air resistance. So first of all, let's find out the energy at this point. So that will be, suppose let's write it as energy at A, UA equal to mgh, right, where m in our question is not given, so it will get cancelled when we will compare, so that is why it's not given. So m times g times, you can write 10 and height you can write 1.5. So this is energy at point A. Now what happens? Entire potential energy at point A will convert into kinetic energy at point B. So Ke at point B is, according to energy conservation, it must be equal to energy at A, but 5% is lost in form of resistance, air resistance. So we just take 95% of energy at A. Now what we do? We write 1 by 2 mv square equal to 95 by 100 of energy at A, that is mgh. I think thing is very clear. Our concern is to find velocity. Cancel m and m. 2 will get multiplied to this side. So v square will be equal to v square will be equal to 2 into 95 divided by 100 into g, take g equal to 10 into height 1.5. Now simplify. 10 times, this is 5 times, then 0.3 times. Now just write it what you are getting. 95 into 0.3. Now find the square root. A root of 95 into 0.3. Now take 1 minute to calculate. You will get 5.3 meter per second. I think thing is very clear. Now let's take next question. Here next question is, a trolley of mass 300 kg carrying a sandbag of 25 kg is moving uniformly with a speed of 27 km per hour on a frictionless track. After a while, sand starts leaking out of a hole on the floor of the trolley at the rate of 0.05 kg per second. What is the speed of the trolley after the entire sandbag is empty? Here there is one question, whether any external force is acting on the trolley. If you observe, there is no external force. Here trolley is moving with uniform speed 27 km per hour. Here uniform speed is given. So in absence of external force, there will not be any acceleration. If there is no acceleration, then speed will not change. So answer is, what is the speed of the trolley after entire sandbag is empty? So it will remain same as 27 km per hour. I think thing is clear. Now next question is an important question and you must know about it. A body of mass 0.5 kg travels in a straight line with velocity v equal to a x power 3 by 2, where a is 5 meter power minus half per second. What is the work done by the net force during its displacement from x equal to 0 to x equal to 2? So here, what is the question? I think you have understood. Let's analyze the question, what they want to say. You have to find out work done. Work done, and limit is given from 0 to 2. You need f dx. If you remember, work done can be found by f dx integration. So here concept of integration is to be applied. But before that, we need force. In our question, mass is given. Mass is 0.5 kg. Now we need acceleration, so that we can write f equal to ma. And another information is given, v equal to a x power x power, it is 3 by 2. So it is x power 3 by 2. So let's write it 3 by 2, and where a is also given, so we can put the value of a here as 5x power 3 by 2 meter per second. So that is value of velocity. Now from here we can easily get acceleration. So for that, if you remember, dv by dt is acceleration. So we can differentiate it. So we write here d upon dt of 5x power 3 by 2. I told you one thing, that d upon dx of x power n is nx n minus 1, no problem. But if you change this, if you write here d upon dt of x power n, then differentiation is not possible unless there is x. So you can do one thing, write here d upon dx x power n, and then to cancel this you can write here dx and this dt over here. So this concept you can apply to differentiate like this type of thing. So here same will happen. You can write here d upon dx of 5x power 3 by 2 times dx by dt. I think there is no doubt. So this will become 3 by 2 times 5 times x power 1 by 2 times dx by dt. And if you remember, dx by dt is velocity itself, which is given as this 5x power 3 by 2. So further we can put this value. So we will get acceleration as, so acceleration will be equal to 15 by 2 times x power half times velocity is 5x power 3 by 2. So what are you getting? 75 sorry, divided by 2 x power 2. So you have got acceleration. Now what you do? You can do one thing, you can find force F equal to ma. So mass is given as 0.5 kg and you have got the expression for acceleration. So you can evaluate it. So W work 0 to 2 and then write this value. This is acceleration. So first you write mass. Mass is 0.5 and this is 75 by 2 I have written ma, and this is x square and then dx. I think thing is clear. F equal to, here if you write F equal to ma 0.5 times this much 75 by 2x square. This is force. Same thing I have written 75 by 2 0.5 into x square dx. Now one thing you can do, if you remember integration. So what is concept of integration? So integration x power n dx gives x power n plus 1 divided by n plus 1, provided n does not equal to minus 1, because in that case the denominator will become 0 and that is not allowed. So here that formula can be applied. So this is 25 by 2 multiplied by 0.5 into, this will become x cube by 3 and then limits 0 to 2. So just you have to write 2 here. So 25 by 2 into 0.5 into 2 power 3, that is 8 by 3. Now take 1 minute to evaluate it. It will come around 50 joule. Do you want that I tell you once again the same thing? So just for your recapitulation, we can do it again. So here we are given mass m as 0.5 kg and you are given velocity v equal to 5x power 3 by 2 and limit is also given 0 to 2. So 0 to 2 work is to be found w and f dx, that is 0 to 2 and here ma dx you did. So what you have to do, m you have and a you can find from here. So dv upon dt is a which is equal to differentiation of this. So you can write 5 times d upon dt of x power 3 by 2. Then you can differentiate it. So you will get 5 into 3 by 2 into this will become x power 1 by 2 and then dx by dt, and dx by dt is velocity itself. So again you can write 5 into 3 by 2 x power half into 5 x power 3 by 2. So you will get the expression 75 by 2 x power 2 and then you can put this value over here and then you can get the work done. I think it is very clear now. Now we have next question. Next question says the blades of a windmill sweep out a circle of area A. If the wind flows at a velocity v perpendicular to the circle, what is the mass of the air passing through it in a time t? Okay, so let's read question further, then I will tell you what is the kinetic energy of the air. If you can calculate mass, then you can apply half mv square. Further, assume that the windmill converts 25% of the wind energy into electrical energy and that A is given this much, V is given this much and the density of air is given. What is the electrical power produced? So let's see the question. Question is interesting. Will you try? Give 1 minute to try. I'm going to help you. Here, all that we need, first thing is mass. So to get mass equal to volume into density, right? And volume will be area into length. So here if we take a velocity, and area into velocity will be volume per second into density. So here we will get mass per second. We can multiply by time. If we put here t, now it is mass. So area is given as A and velocity is given as V. Density, suppose we take as rho and time we can take t. So expression for mass will be AV rho t. Is it okay? Now if we need kinetic energy, so for kinetic energy, what do? We write 1 by 2 mv square. So we can write 1 by 2 m, in place of m we can write a v rho t into v square. So just write v cube, because v square will get multiplied here. So 1 by 2 a v cube rho t. We have got kinetic energy. But assume that the windmill converts 25% of wind's energy. So this is kinetic energy of the wind. 25% of it is converted into electrical energy. So what is the electrical power produced? So energy per second. So power produced is 25% of this. So 25 by 100 of this 1 by 2 a v cube rho divided by time, because you need power. So when you divide by time, this will convert into power. So you have got 1 by 4. So 1 by 8 of a v cube into rho. Up to here, no doubt. Now what you can do, you can put the values. So values are given, like area is 30, velocity is 36 km per hour, and density is also given. So let's put the values. 1 by 8 into area is 30 multiplied by velocity. Velocity is given as 36 kilometer per hour. So 36 into 5 by 18 will convert it into meter per second. So 2s are, so 10. And so we need 10 cube into density is given as 1.2. Now here just give 1 minute to evaluate, then I will tell. So you will get 4.5 into 10 to the power 3 watt. I think you've understood. Now let's take next question. What is next question? Next question says, a person trying to lose weight, dieter, lifts a 10 kg mass 1000 times to a height of 0.5 meter each time. Assume that potential energy lost each time she lowers the mass is dissipated. How much work does she do against the gravitational force? Then second part is, fat supplies 3.8 into 10 power 7 joule of energy per kilogram, which is converted to mechanical energy with a 20% efficiency rate. How much fat will the dieter use up? Okay, question you have understood. Let's try. I think it is visible. Okay. Let's take the information. So M is given as 10 kg. Height is given as 0.5 meter. and number of times is given as 1000. Here we have to find out work done against the gravitational force. So you know work done against the gravity is mgh. For once, here person is lifting it 1000 times. So just multiply by 1000, you will get the value. So here 10, let's write g as 10 and height as 0.5 into mgh, 1000 joule. So this is the amount of work done in lifting 1000 times 10 kg mass. Now let's consider the amount of fat consumed. So 1 kg of fat gives 3.8 into 10 power 7 joule of energy. But efficiency is 20% only. So you can say 1 kg fat will gives 3.8 into 10 to the power 7 joule energy, but only 20% efficiency is there. So this is 1 kg fat. Now suppose say x kg fat is used. So to get x kg fat, very simple, the energy required divided by this much energy given by 1 kg fat. So here x kg fat will produce the energy required that much. So we can say, we can write it like x times this much, 3.8 into 10 to the power 7, is it correct value? Yes, into 20 by 100 is equal to energy required. Either you write this in terms of power or just write 0.5 into 10 to the power, just count 1, 2, 3, 4, 5, 10 power 5, or x equal to 0.5 into 10 to the power 4 divided by this value. So this will become 1 by 5. So 5 will get multiplied here and the remaining things will go in denominator. So 3.8 into 10 to the power 7. Now take 1 minute to evaluate and tell me. So you will get 6.95 into 10 to the power minus 3 kg. I think you have understood. Now we are going to take another question. The next question is, a family uses 8 kilowatt of power. Direct solar energy is incident on the horizontal surface at an average rate of 200 watt per square meter. If 20% of this energy can be converted to useful electrical energy, how large an area is needed to supply 8 kilowatt? Compare this area to that of roof of a typical house. So here energy need is how much? Energy need is, you can say This is power. So let's write it. Say P needed is 8 kilowatt. Kilowatt means 8,000 watt, right? And here direct solar energy incident on the surface at an average rate of watt per square meter. So 1 meter square area gives 200 watt energy, right? So we can say, so energy per second will be energy per second, that is power, will be equal to this incident energy 200 watt per meter square multiplied by, here you have to multiply, since meter square is in denominator, so here you have to multiply area square. Suppose here area, not area square, but you have to multiply by required area. So this will become just 200 watt for 1 meter square. Now energy needed means energy per meter square into area, and then it's a 20% efficiency is there, right? Did you understand? Energy, if you analyze this, so here in watt per square meter is given. It means energy upon time is given in terms of watt per meter square. So here either you write here just area into time, then you will get this energy upon time will become power, so watt per meter square. So to get ET, what you have to do, this you can say power divided by area is given, but you need just power, right? So for power you have to multiply by area because it is given like 200. So you need power, so power you can get 200 multiplied by area. The same thing I have written here, so 200 times area, and only 20% efficiency is there, so just write this much. Now this thing will provide this much energy, so if you equate the two, so on equating, what do you get? Here 2 0 will cancel out, this will come 40 times area is 8,000, or area equal to 8,000 divided by 40. 200 meter square. So 200 meter square means what? What will be the dimension of house? Length, width in that term, if you consider. Suppose you take 14 meter, 14 meter. What will be the area? 14 into 14, 196 meter square. Here you are given 200. It means little larger than this, but if you write 15, so 15 to 15 will become 225. So the dimension should be 14 point something, that you can evaluate, or just do one thing. If you take square root of 200, you can get direct value. What will be the dimension if we take square shape house? Otherwise it can be rectangular also. So 200 can be written as 200, can be written as, suppose if we write say 20 into 10, 20 meter length, 10 meter width, it is possible. Other possibilities are also there. So I think you have understood, although this comparison is not to be made, only your purpose is to calculate the area. Thank you for watching. team educate